Welcome back to my channel's Ultrasound Physics. And in today's lecture, we will discuss wave, pulse, wavelength, frequency, and amplitude. Please stay tuned with me and let's proceed to our next slide. So, as far as the definition of the wave is concerned, that wave is anything that transfer energy from one place to another place. There are different waves that carry energy from one place to the other place, and they have different names and they have different characteristics. But our ultrasound waves carry pressure energy from one point to another point. And we also uh, discuss that wave is actually a one cycle, a crust, a trough, and this area is called area of compression, and this area is called area of rarefaction. Let's define pulse. That what is a pulse? So, in order to define pulse, we need to draw again our favorite one cycle of the wave, and that is here, crust and trough. And if I add another cycle to the first one, now these are two cycles. So the group of two or more cycles, two cycles, three cycles, four cycles, the group of 3, 4, 5 cycles is called a pulse. And it has different areas, like the same one as we discussed in when we discussed the wave. It has crust, trough, and the trough. And the distance between the two crusts is called wavelength, and wavelength is represented by a Greek letter lambda. And the distance between two troughs is also called a wavelength. This wavelength determines that a pulse is short or a long. And we will discuss in coming slides and in coming lecture in details that how this wavelength affects the length of the pulse and frequency of the pulse. Let's discuss the amplitude of the wave. What is the amplitude? And it's a very important term. And it's frequently used in diagnostic medical sonography. Again, we will have to switch to our favorite one cycle wave. So if we plot a graph between time and pressure, here is time and here is pressure. Pressure increases in this way and time increases in this way. And this is called the neutral line. Neutral line, a resting position, or zero line. And above this line, all values will be in positive. And below this line, all values will be negative. So we have discussed that when a pulse wave travels in a medium, it changes the pressure and density of that medium. And suppose the pulse starts from 0 and time lapse, and with the change of time, pressure of the medium increases, and we plot a graph between this increasing pressure and increasing time, and we get an ascending curve and a descending curve. Ascending curve represents the increasing value of the pressure and density, and descending curve represents the decreasing value of the pressure and density. Now, when pressure and density keeps on increasing with the lapse of time, at one point it attains the maximum value, and that point, if we take a distance of the maximum value of the pressure to the zero line, this is called amplitude. Similarly, the decreasing values of pressure and density becomes zero, that is the original pressure and density of the medium, and then it start again declining, and the negative value becomes maximum at some point, and the distance between this maximum point and the zero line is called amplitude, and it is the negative amplitude. So we got two amplitudes, positive amplitude and negative amplitude, in a wave, in a single cycle of a wave. So this amplitude is called positive amplitude because it is on the positive side of the neutral line or above the neutral line, and this amplitude is called the negative amplitude because it is on the negative side of the pulse. So amplitude is represented in decibels, and it represents the height of a wave, the strength of the wave, loudness of the wave, that how sound wave is loud. And loudest animal on this planet are the sperm whales, and the amplitude of the vibration is so loud that is about 320 decibel, that it can easily kill an adult human being. So again, snapshot of a wave, one cycle, crest, trough, and in this picture you are seeing many cycles, and there is no break, there is no grouping in it. So such waves who are continuous, these are called continuous waves. And but if these cycles are in the form of group, like group of 2, or group of 3, so these groups are called pulses. This is a continuous wave because it's not in the form of group, but these are group of 2 cycles, so this pulse will be called 2-cycle pulse, and if there are 3 cycles in it, so this pulse will be called 3-cycle pulse. We will discuss in detail in coming lecture that how these pulses are used in diagnostic medical imaging, and their length, how their length depend on the resolution of the image. So, and we also discussed that when a wave move in a medium, it not only change the pressure and density of the medium, but it also make the particles of the medium move to and fro or back and forth, and that is why ultrasound waves are called longitudinal wave. And on the basis of the movement of the particles of the medium when a wave passes through it, we have different types of waves, like when a wave passes through a medium and particles start jumping up and down or moving perpendicular along the direction of the wave, so such waves are called transverse waves. All electromagnetic waves are the transverse waves, and such waves do not need medium for propagation. Radio waves, gamma rays, light waves, and infralight waves, microwaves, radio waves are all the example of the electromagnetic waves. And there is a third type of wave that when it passes through a medium, it makes the particle of the medium to move in a circular fashion. So these are called surface waves, and water waves are one of the example of the surface wave. So on the basis of particles, the movement of the particles of the medium, we have three types of waves. Transverse waves, up and down movement of the particle of the medium, circular movement of the particles in surface waves, and we discuss a lot of time that the movement of the particle is back and forth. And once again, I want to repeat that when a wave passes through a medium, particles do not leave their position, but they only vibrate to and fro about their main position or about their fixed position. So in a medium, only energy is transferred, not the particles. Particles are not transferred from one place to the other place. Only energy is transferred. In case of ultrasound waves, pressure energy is transferred, and in case of electromagnetic waves, electromagnetic radiation energy is transferred from one place to the other place. So these are examples of the surface waves, and when wind rubs against the surface of the water, such waves are produced. So there are different definitions of wavelength. So if I draw again one cycle of the wave, so the distance occupied by a wave is called a wavelength. Distance occupied by wave called wavelength. And second definition is the distance from the start of a wave to the end of the wave is called a wavelength. And where the first wave comes to an end, second wave starts. So there would be a third definition of the wavelength, that wavelength is the distance from the start of a wave to the start of the next wave. And the distance between two consecutive troughs is called a wavelength. So wavelength is a distance, and it is measured in meters, millimeters, and lower units. We will discuss it in coming lectures. Let me erase it, and then let's proceed. So these were the different definitions of the wavelength. Let's discuss something about speed, velocity in the time period. We need one cycle of our wave. So, and time to complete one cycle of a wave is called time period. And it is represented by the capital T and the units of the same of that of time, that is second. So, and speed is again the distance, as wavelength is a distance. So speed is also a distance. Distance covered by a wave in 1 second is called speed. It is denoted by S, and the units are the same as of wavelength, millimeter, centimeter, etc. But if we add direction in speed, this is called velocity. Suppose the distance covered by a wave, this is the distance covered by a wave in 1 second towards east, towards west, towards north. Now I have added a direction in the definition of the speed. Speed is the distance, this is the just distance in any direction in 1 second, while velocity is the distance covered by a wave in 1 second in a particular direction, like in east, west, or any other direction. And we will come across with this this term when we will discuss medium. So velocity of the sound waves depends upon stiffness of the medium, and density of the medium. So as the stiffness increases, velocity increases, velocity of the sound increases. As stiffness decreases, velocity decreases. So in order to determine that in what medium the velocity of the ultrasound wave will be high and in what medium it will be low, we need to have significant understanding of the stiffness of the medium, and we will discuss in detail. So velocity and stiffness has a direct relationship. As stiffness increases, velocity increases, and vice versa. While there is an inverse or opposite relationship between velocity and density, if density decreases, velocity increases. And when a density increases, velocity decreases. They are inversely proportional. So velocity and stiffness are directly proportional, and velocity and stiffness are directly proportional, and velocity and densities are inversely proportional. And the exact formula, if you put an under root stiffness of the medium divided by the density of the medium, it is the main formula for the velocity of the ultrasound. So we have already discussed that the distance covered by ultrasound waves in 1 second in any direction is called speed, and the distance covered by ultrasound waves in a particular direction, that distance is called velocity, and the time to complete one cycle is called time period. Now I want to again make some difference, that the time to complete one cycle is called time period, and the space occupied by one cycle is the wavelength. And a number of cycles passing through a particular point in 1 second is called frequency. So this is the difference between time period, wavelength, and frequency. And remember again and again that frequency is cycle per second, one cycle in 1 second. And if there are 2 cycles per second, the frequency is 2 cycle per second, and 1 cycle per second is also called hertz. Here the frequency will be 2 hertz. If there are 3 cycles in 1 second, the frequency will be the 3 cycle per second, or 3 hertz. So according to the frequency, we have different kinds of waves, like audibles, infrasound, and ultrasound. The 20 hertz and 20,000 hertz. The normal range of an ear lies normal hearing range of human ear lies between 20 hertz and 20,000 hertz, and any sound of frequency below 20 hertz is called infrasound. Infra mean below and ultra mean above, and any sound having frequency above than 20,000 hertz is called ultrasound. And we also discussed that we can write 20,000 like this, and 1,000 is also called kilohertz. And we can, so now the range will be 20 hertz to 20 kilohertz. And this number, we can write this number like this. If you put a decibel here, 10 raised to power, count the number of 0, 1, 2, 3, 4, 10 raised to power 4 hertz. So it's another way to write the frequency of 20 kilohertz or 20,000 hertz. So cycle per second is called hertz, and 1,000, kilo mean 1,000, and kilo mean 1,000, and mega mean million. When you say the frequency is 1 hertz, it means 1 cycle per second. 1 cycle is passing through a specific point in 1 second. If you say 20 kilohertz, it means 20,000 hertz, 20,000 cycles are passing through a specific point in 1 second. And when you say megahertz, so it means 1 million cycle are passing through a specific point in 1 second. And 1 million mean mega. Let's erase it and move forward. The units of frequency we have discussed. At this point, I'm not going to throw a lot of mathematics and mathematical calculations, but at some point we will do some math with regard to the relationship between the different entities of ultrasound waves. This is all for today, folks. Thank you very much for watching this video. See you in the next video. Please like and subscribe my channel Ultrasound Whispers to learn together. Thank you very much.